The least common multiple is the smallest number that both numbers can go into. I like that definition. And as we do some examples, you kind of figure it out. Let me just say this, guys, in case you get confused between greatest common factor, GCF, and least common multiple, because it's easy to do. The GCF will always be smaller or equal to the biggest number in the set. For example, let's say we had 10, 20, and 40. Okay, I'm sorry, it can't be bigger than the smallest. So the GCF of that would be 10, right? Yeah. The least common multiple will always be bigger or equal to the biggest number. So the LCM is always bigger than the GCF, okay? And if you think about it, L comes after G in the alphabet. So maybe that'll help you remember that the LCM is at least bigger than or equal to the biggest number. The GCF is smaller than or equal to the smallest number. So the least common multiple, like he said, is the smallest number that a set of numbers can go into evenly. Now the key word is evenly, okay? You could say that 7 goes into 15, right? But not evenly. So there's no way that 15 could be the LCM of 7. So make sure you understand that it has to go into it evenly. Definitely need to write this definition down. Shouldn't have to tell you. It's funny how you won't write it down and then you go and take a quiz and it's like, the question is, what's the least common multiple? Then you get it wrong and you wonder why. You had nothing to study for over. If you write it down enough, it'll stay with you forever, my friend. Okay, everybody good with the definition of least common multiple? It's got to be, usually it's going to be bigger than the set of numbers, but the smallest it could be is the actual biggest number. Unlike the GCF, the LCM is always greater than or equal to the largest number in the set of numbers. You don't have to write that down, but just know that, okay? LCM is bigger than GCF. You could write this down, okay? LCM is bigger than GCF. And again, maybe to remember that, L comes after G in the alphabet. All right. We're just going to look at this one. I'm not going to go over the steps with you for this one. This is just for the sake of understanding. So the biggest number that both 6 and 8 go into. Now, here's a trick you can try. You can always try the biggest number. But does 6 go into 8? No, okay? Let's talk about some numbers that don't work. How about 12? 6 goes into 12, right? But 8 doesn't. Okay, we could try 16. 8 goes into 16, but 6 doesn't. So 24 is the smallest number that will work for both of them. In other words, 8 goes into 24 3 times, 6 goes into 24 4 times. So it's the smallest number that both numbers go into. Now I'm going to show you guys exactly how this plays out, okay? I'm going to teach you 3 steps that are going to give you the right answer every time. So let's look at 9 and 12. And yes, you need to write this down for sure, especially the steps, as well as how to get there. So just like with GCF, we are going to find the prime factorization of both numbers. And we know that 9 is 3 times 3, and 12 is 3 times 2 times 2. Okay, I'm about to go over step 2, which is different than GCF, but step 1 is the same. You're going to find the prime factorization of both numbers. Step 2, circle the highest power of each factor. Let me explain this. Notice how over here, 3 occurs twice, okay? Over here, it only occurs once. So you're only circling the highest power of the factor. In other words, where it occurs the most, which it occurs the most for the 9, which is 3 squared. You don't circle the 3 to the first because it's not the highest power. Now over here, for the 12, we have 2 squared, which is obviously the highest power. This doesn't even have a 2. But say that one had 2 to the first, you wouldn't circle that one. You'd only circle the highest power of each. Okay? Any questions about that? Because I know that can be a little confusing. So when you're prime factoring for LCM, it might help you to write them in exponential form. In other words, 3 times 3 is 3 squared. 2 times 2 is 2 squared. So once you've, yes. Okay, so again, circling the highest power of each factor. So we've circled 3 squared and we've circled 2 squared. Now, if you're doing GCF, it'd be different, right? You would just circle the factors they have in common. This is not GCF, this is LCM. Okay, so now that we've done step 2, we can multiply what we circled. In other words, we circled 3 squared and we circled 2 squared, and we can go ahead and multiply those together. And 3 times 3 times 2 times 2 is the same as 9 times 4, which is 36. That's going to give us the smallest number that both numbers go into. So for step 3, you multiply those circled factors to get the LCM. And every time you get an answer, you should at least look to see if it makes sense. Does 36 make sense for 9 and 12 being the least common multiple? Yeah, right, because 12 goes into 36 3 times. 9 goes into 36 4 times. Sometimes it might help to think, is there a smaller number? Well, let's try 27, right? 9 goes into 27. 12 doesn't. 30 doesn't work. Neither one goes in. So you try a few numbers. Right. What were you going to say? Now that we got the hang of it, let's go ahead and do this example 4 and 14. Again, step 1, we're going to prime factor. So what's the prime factorization of 4? Prime factorization of 14? 7 times 2. Okay, so again, when we're doing LCM, we want to write in terms of powers, so that would be 2 squared. That way we know which, these both have a power of 1 in case you want to do that. You don't have to. So leads us to step 2, circle the highest power. So we're only going to circle 2 squared once, or the 2 once. That's the highest power, right? That's bigger than 2 to the first. So we won't circle the 2 to the first. How about 7? Will you circle that? Yes, it is. Even if it's the only occurring factor, it's still the highest power, right? Okay, so that's right. Yeah. So if you had a 7 squared and a 7 to the first, you'd only circle the 7 squared. If you have a 7 to the first and no other 7, it's still higher, right? There's nothing else there. So if it's the only occurring factor, you'll naturally circle it. Okay? So that's step 2. Step 3, we're going to multiply the circled factors to get the LCM. So we're just going to take 2 squared and multiply by 7, and that will give us the LCM. So that's 4 times 7, right? Which is 28. So 28 is the smallest number that 4 and 14 go into. Again, we can check it. 4 goes into 28 7 times. 14 goes into 28 twice. And there is no smaller number that would work for both of them. So therefore, the answer is 28. Okay, example 3. Anybody know the shortcut for this one? Raise your hand if you can see it. Huh? Okay. What's the... Yeah, since 15 goes into 45, if one number goes into the other, then you automatically know the LCM, okay? I mean, there's no smaller number than 45. You see what I'm saying? That it just doesn't make sense, right? Like 30 wouldn't make sense because 45 can't go into 30, so it can't be smaller than the biggest. But anyways, if we do want to work it out, this would be 5 times 3. That would be 15 times 3, which turns into 5 times 3 times 3. So we could write this as 5 times 3 squared, and this would be 5 to the first times 3 to the first. So which factors would we circle? Yeah, now in this particular case, it doesn't matter which 5 you circle because they're the same. The key is to only circle one of them. So I'll just circle this one. And then this one's, the 3 squared is bigger than 3 to the first, so we'll circle that for step 2. And then for step 3, we'll multiply them, see if we were right. What is 5 times 3 squared? 45, right? So we were right. So that shortcut definitely works. Go on to the next example. Do 3 numbers, 3, 6, and 15. What's the smallest number that they all go into? So let's go ahead and prime factor 3. Well, guess what? It's already prime factored, right? All right, how about 6? 3. And then 15? 3 times 5. Okay, so 3 only occurs once in each of those, so we can only have to circle it once. How about 2? Only occurs once, I have to circle it once. And how about 5? So we're circling the highest power of each, right? And we're only circling it once. Last step is to multiply the factors, get the LCM. So what is 3 times 2 times 5? 3 times 2 times 5. Now let's take a look and see. Do all these numbers go into 30?
Yes.
And is it the smallest? I think it is, right? I mean, 15, the next choice would be 15, right? And they don't go, right. They don't all go into 15. Right, that's right. So it's always good to kind of check to make sure it makes sense. Let's do 2 more. 4, 6, and 7. All right, what's the prime factorization of 4? Turn around. Okay, 6. And then 7. 7 is a prime number, so it's already prime factored. Okay, so on the left, I'm going to write this as 2 squared. And the other 2 are just to the first power. All right, so which 2 would I circle? Step says circle the highest power of each factor. So which one would you circle? 2 to the second is bigger than 2 to the first. Okay, and then these only occur once, so we're only going to circle them once. So for step 3, we're going to multiply the circle factors. All right, what is 2 squared times 3 times 7? It'd be 4 times 3 times 7. So that's 12 times 7, which is 84. Okay, guys, this one's kind of, when you're looking at these numbers, to me it looks like 84 is really big. But think about this. This being a prime number, okay, and this only having a 3 in it and a 2, and this having 2 2s. You really can't find a smaller number. Now we could try multiples of 7 just to check. 21 doesn't work. Yeah. So 21 doesn't work, right? 14 doesn't work. 28 doesn't work. 35 doesn't work. So this one's kind of surprising, but 84 is the smallest number that all three of those go into. One more example. 10, 15, and 25. We're not doing the GCF. You're right, 5 is the smallest number that goes into them. Remember, the least common multiple is the smallest number that they all go into. Well, in this one, we're really going to have to do the work, so we're going to have to prime factor first. So this is 5 times 2. What's 15? 5 times 3, 25. 5 times 5, which is the same as 5 squared. Okay, so first of all, what's the highest power of 5 in these three? That's right. What's the highest power of 3? What's the highest power of 2? Okay, so LCM. We're going to multiply all three of those together. So we're going to multiply 2, 3, and 5 squared. Okay, so it's going to be 6 times 25, which is what? So 25 times 4 is 100, plus 25 plus 25 equals 150. Guys, it's 6 quarters. 6 quarters makes $1.50, right? Okay, it's the same concept. So guess what? The smallest number that all three of these go into is going to be 150. Okay, you can try some other ones. How come 125 doesn't work? Right, so it has to end in a 0. What about 105? 15 goes into 105, but 25 doesn't, and neither does 10. 15 does not go to 100. So 15 times 6 is 95. And so then if you, or wait a minute. No, 15 times 6 is 90. If you added 15 again, you'd be 105, so you're skipping over 100.